In this lesson, we will look at section 19, zeros of a polynomial function, and this is the second part. The use of the calculator is not allowed. So we look at the given function below, and we are told that this is a cubic polynomial function. And because we're told that this is a cubic polynomial function, we can right away say that the degree is 3. Now, as we learned in the previous part of section 19, we know that to see real zeros will show up along the x-axis, whereas complex zeros will not show up crossing the x-axis. So because we know that this is cubic, we're expecting 3 answers. And because this graph crosses the x-axis 3 separate times, we have 3 real zeros. And as far as the positive zeros, we're going to look at the positive side of the x-axis. So we can see that that's going to cross 2 times, so there's 2 positive zeros here. And then it's going to cross the negative side of the x-axis 1 time, and that means we have 1 negative 0. And again, because all 3 of them are accounted for as far as being real solutions, we won't have any complex zeros in this case. So take a look at the next example and see what you can fill in. Now this time we see that this is a 5th degree polynomial function, so we can say that the degree is 5. Now here we can see as far as positive zeros, it does intersect the x-axis on the positive side of 0 1 time. So we can put 1 there. Now as far as negative zeros, we need to realize that this right here is what it looks like when we have a double root. And it's because it is tangent to the x-axis. We can see it doesn't actually pass through the x-axis, but it touches it and then switches directions. So there is one position here, but it is considered a double zero. As far as how many solutions we're getting, we can kind of think of this as 2 right now. This is like having 2, 3, so we're at 3 so far. But in order to have a 5th degree, we would need to have 2 more solutions. And we don't have any other places where they cross the x-axis, so there's no more real solutions, and that means that the 2 remaining solutions are complex. And one thing we want to remember about the complex zeros is that they have to come in pairs. So we definitely couldn't say that there were 3 of these or that there was 1 of these. It has to be an even number of complex zeros. So try the next example. So with this one, we see that it's a quartic polynomial function, and that means that the degree here is going to be 4. So we're looking for 4 solutions. As far as positive zeros here, we do see that in 2 positions, we are either tangent to or crossing through the x-axis. Now this again is going to represent a double root. So although we have 2 positions here, we do want to indicate that one of them is a double zero, and that would again mean that this accounts for 3 of our solutions towards the total of 4. Then when we talk about negative zeros, we do see that it crosses the negative side of the x-axis 1 time. So that is going to be our other solution. Now again, this counted for 3, that's 1 additional, so that gave us our total of 4 that we're looking for the degree. And that means that we have no complex zeros in this case. Try the next example. And in this example, we can see, since this is a quadratic function, that the degree is going to be 2. That means I'm expecting 2 solutions. Now here, it never crosses the x-axis, either on the positive or the negative side. So I'm going to say 0 for positive zeros, and same thing for negative zeros. And then because I still need 2 solutions, that means that this must have 2 complex zeros in order to, again, come up with the degree of 2 here. Try the next example. And here we see that this is a cubic polynomial function, therefore the degree is going to be 3. As far as positive solutions, we do have 1 positive solution here. Again, that is going to be a double zero because it doesn't cross through the x-axis. It is tangent to. It comes up and touches it, and it reverses directions. So then from here, we see that we do have 1 negative 0. And again, because this counts for 2 solutions, this is 1 more. We are at the 3, meaning that we have no complex zeros. Try the next example. And with this, we see that it's a 6th degree, which means that we can write a 6 here. As far as the positive zeros, I see 1 position here, and that is going to be a double zero. As far as negative, I see 1 here, but again, that's going to be a double zero, or a double root is what we also can call that. Now, from here, again, this counts for 2 solutions. This counts for an additional 2 solutions. So far I'm at 4 zeros, and then I'm looking for, I would need 2 more. And again, we want to make sure that this is always an even number here. So now we take this model here, and even though we're not provided with the graph, now we're going to come up with all these different parts of this. So here we can see that again, like we did in the last part of section 19, we would multiply x times x squared, and we would get x to the third. So that's going to tell me that my degree is going to be 3 here. Now, from here, we know that this is going to give us a positive 3, so I am expecting to have 1 positive 0 here. I need to figure out this section right here, whether this is going to give me real solutions or if they're going to give me complex zeros. And I'm going to do that by just figuring out the discriminant, b squared minus 4ac. So when I do that, 1 squared minus 4 times 1 times 9, I see that this is going to stay a 1, and then this is going to be minus 36. And 1 minus 36, that's definitely going to be negative. So since this is less than 0, that means that we are going to get a negative number there. Therefore, those are going to represent 2 complex zeros here. So again, the degree was 3. We had the 1 positive 0 from the first set of parentheses, that first factor there, and then no negative zeros. And then we are going to get 2 complex zeros. And this time we're not trying to find those complex zeros. We just want to indicate that there are 2. So do the same thing with model 2. And here, this time it's factorable, this set of parentheses, so we can go ahead and factor that to see what types of solutions we're going to get. Now again, here, if I multiplied x times x squared, I would get x to the third, so our degree is 3. As far as positive zeros, if I set x minus 4 equal to 0, that's going to give us a positive 4. So that's going to be one of them. The other one is going to be x minus 3. If I set that equal to 0, it gives me positive 3. So 2 of these are going to be positive zeros. From here, now, as far as negative zeros, I take this x plus 4, set that equal to 0, I would get negative 4, and that means I'm going to get 1 negative 0. And here, all solutions are accounted for, so we aren't going to have any complex zeros in this case. And for the remaining examples, you are going to look at filling in the chart for each and then matching them to the graphs that will be provided.